Before you use a z-test for testing a hypothesis about proportions, there's conditions that have to be met. If they're not met, then we'll make like false conclusions. We'll like say that there's significant evidence when there actually isn't. Okay. So if you got a survey of 100 randomly selected people in city A, 85 supports, and there's a bunch of information about a study that they did. The conditions are listed down here in the multiple choice options that you have. Okay. The samples need to be from a random sample, which means you can't pick like every fifth person that comes out of the coffee store. It's got to be a random sample of your population. The samples need to be independent, which means like picking Joe doesn't mean you're more likely to pick Jack, right? An example of dependent sampling would be if you pick a person and their wife to tell you who they're going to vote for president. That's dependent because one was dependent on the other. So they have to be independent for this to work. And then these little formulas have to hold. Okay, N1, which means the sample size of your first one times the proportion of your sample one. And I think we usually use hat. I don't know if I just the question I copied down doesn't have it. Maybe, yeah, I think they might use, Newton might use this for the sample proportion. But either way, the sample size times the sample proportion, when you multiply those, it needs to be greater than or equal to 5. And 1 times Q1, which means just the opposite. Q just means 1 minus P. So this needs to be greater than or equal to 5. Sample size 2 times proportion 2 needs to be greater than or equal to 5. And then sample size 2 times 1 minus your sample proportion needs to be greater than or equal to 5. Okay, so the way you can check these is find out your N1. Survey 100 random select city A. There was 100 people in the first sample. And then there was 100 people in city B's. City B's sample. So that's N2. And then the proportion of people that met the condition, 85 support increase in government spending. So this is 85 out of 100. And so for P2, there is 82 out of 100. So convert that to a decimal if you want with a calculator. Okay, so now we can check out each of these individual formulas. Okay. Let's start with the first one over here, N1 times P1. Here's our N1. Here's our P1. If you multiply 100 times 0.85, that gives you 85. That is greater than 5, right? So that's good. That means it's satisfying this condition. It's at least 5. Let's check the next one on our list. This one was written out like over here. That Q stands for 1 minus P, right? So this is N1 times 1 minus P1. So here is 1 minus P1. P1 is 0.85 as a decimal. And you multiply that by N1, that's 15, that's greater than 5. So this condition's checked. N2 times P2. The little numbers must be lost when I copy this picture over. N2 times P2, that needs to be greater than 5. So N2 is 100, P2 is 80.82. So if you multiply those together, that makes 82, and that's greater than 5. So this condition is checked off. N2 times 1 minus P2, this would be 100. If we do 1 minus 0.82, so that's 100 times 0.18 here. That's greater than 5, right? So all these are checked. So this holds. Not all the values are at least 5. That condition's actually met. We're not going to check this one off because that's not true. All of these are at least greater than or equal to 5. We plugged in the numbers into the formulas, into each of these 4 formulas, and they were all greater than 5. Okay, let's check the other conditions. The sample size, samples are not random samples of the populations. They said randomly select people in city A, randomly selected people in city B. So we're going to assume that they're all random. And the samples are not independent. They're from 2 different cities. There's no reason, they haven't given us any reason to think one sample was dependent on the other. So we're going to go with all conditions are met. So similar example here. product analyst knows whether the proportion of people in her state prefers hot dogs and hamburgers varies from state to state. 50 people from Idaho, so I'm going to write N1 equals 50. And 50 people from Oklahoma, so N2 equals 50. That's our other sample size. 18% of the people in Idaho prefer hot dogs, so P1 is 0.18. And then for what was the other? Oklahoma, P2 equals 0.22. Are the conditions met? Reading through to see if they say anything to make us think that they're not independent. I don't see anything. They say 50 random people. 50 random people from Oklahoma. So this sounds good. Random sample. There's no reason to think that picking somebody from Idaho is going to affect the people you pick from Oklahoma, or picking one person from Oklahoma means you're going to pick another person from Oklahoma. So this sounds good. This sounds good. We got to check these. So that means you got to do N1 times P1. So 50 times 0.18, that gives us 9. And then times Q1. Remember, Q is just the complement. You just do 1 minus 0.18, like we saw in the last problem. So it's 0.82. If you do 0.82 times 50, that's surely going to be greater than 5, right? And then over here, 50 times 0.22 gives us 11. And then we have Q2 is going to be 0.78 in your calculator. It's just 1 minus 0.22. So if you multiply those, that's definitely going to be greater than 5, because it's an even bigger number. Oh, wait, sorry. I did times P again. 39. They're all at least 5. So these 3 conditions are satisfied. So those are the 3 we should check off.